Hello friends, I have designed computerized DC motor direction controller. So first of all, see the process. See carefully. What is happening? See carefully. See when I'm passing F character, when I'm passing F character to the microcontroller. See, motor is rotating in forward direction, and when I'm passing R character to the microcontroller, motor is motor's direction changes to reverse, means motor is rotating now in reverse direction. And when I press S and pass it to the microcontroller, means when I'm passing S character to the microcontroller, the motor stops. See once again. See, forward, reverse, forward, reverse, stop. Interesting, right? Right. So see here what I've used. See, so I've used microcontroller. This is the brain. I'm very fond of this microcontroller, Arduino Nano. It is very useful, very much. And the whole the project becomes very much simple by using this microcontroller. This is my best buddy. Okay, so see, I've used this microcontroller, and then here, see, I've used 4 transistors. See, these small transistors is basically driving these 2 power transistors. These are the 2 power transistors, and these 2 power transistors is basically driving these 2 relays. Okay, and see here there are many resistors. So these resistors is basically limiting the current. So see, these resistors, see, these resistors is basically limiting the base current to these small transistors. Okay, and these resistors also limiting the current to the base of these power transistors and all. Okay, so, and see here two diodes I have used here. This diode is basically freewheeling the transient voltage which is generated by this relay coil, and this diode is freewheeling the transient voltage which is generated by this relay coil. Okay, and what is left now? Yeah. See, this is basically a bridge rectifier arrangement. Okay, 4 diodes I have used and 2 capacitors to filter out the ripples. So this is a bridge rectifier arrangement. Okay, so what is happening from here? See here, and this transformer. So this transformer's AC signal is being rectified to DC, and that DC voltage is being utilized to drive these 2 means to power up these 2 relays. These 2 relays are driven by these 2 transistors. Okay, these 2 transistors is acting like a switch, and to power this relay up, this transformer I've used in practice. Okay, so this is the configuration of the control circuitry, and this microcontroller is being powered by this Android mobile. Okay, this phone is powering up the microcontroller via this USB cable, and also serial communication is being processed between this mobile phone and this microcontroller. Okay, and by serial communication only, this I'm passing the values to the microcontroller, and accordingly the process is happening. So basically I have implemented a logic behind it. Okay, so and that is the that is the beauty of this my microcontroller, and that is okay, that's why it's very much interesting. So what happens basically, this microcontroller generates signals, and that signals is being amplified via these transistors, and everything happens. Okay, means that weak signals is being fed to these relays. That what is the signal? Digital signals 1010. Accordingly, when I pass the value, say this pin generates one signal, logic one signal, that is passed to this transistor. This transistor turns on, and and this transistor basically then this transistor turns on this transistor, and this transistor basically turn this relay up. So here basically these transistors is acting like a switch, and the signals is being coming out from this microcontroller, and eventually these relay just operates. So ultimately, with the help of this microcontroller, I am basically driving these two relays. That is the concept. So what is the purpose of these two relays? Why I have used these relays? I'm coming. See here. I've used transformer. Here also I've used a transformer that is 12012, and this also a 12012 transformer, sorry, means 230 by 12012, and this also 230 by 12012. What is the main difference between these two transformers? The main difference is its current handling capacity is more, and its current handling capacity is less. So this transformer is basically driving this motor. Okay, so see how I have connected. See here, see there is a center tap rectifier. Okay, and the output of this center tap rectifier is a DC, and it is 12 volt DC voltage I have provided to the field winding of this motor via this relay. Okay, what I have done, I have provided a DC, and this center tap rectifier is basically converting the AC signal to DC signal, and that's DC signal I have provided to the field winding of this motor via this relay. Okay, and see here, from these two terminals I am getting 24 volt supply, and that 24 volt supply I have fed to the armature of this motor via this relay. Okay, it is clear now. Means the center tap rectifier, from the center tap rectifier, oh sorry, one thing I have missed. I need to convert, means in this 24 volt is basically AC signal, so I need to convert that to DC. So see here, small bridge rectifier. This is a bridge rectifier that can handle a more current, means its current handling capacity is more. So via this bridge rectifier I have provided the voltage, DC voltage, to the armature of this motor via this relay. Okay, as this is a DC motor, so I have to give DC voltage to drive the motor. Okay, is it clear? I hope it is clear. Okay, so now you have to understand that how direction change take place. Okay, so what is the theory behind the direction change of DC motor? So it is very easy process. changing direction of a DC motor is very easy, very simple. What is the process? You need to just change the polarity of the DC motor. Polarity means what? And whose polarity? I'm coming. You have to change the polarity of armature or field. Means not or not both. Okay, means you can change the polarity of this armature. Means when you are supplying here plus and here minus, and if you are reversing it, means if now you are providing here minus and here plus, the direction will change. Okay, and that is in case of armature. And in case of field, this is the terminal of field. You can also change the polarity of field. Means you are now at present you are giving plus and here minus. Okay, and now means initially if you are giving plus here minus and now you are giving here minus and plus, the direction will change. Okay, but not both. Means if you are simultaneously changing the polarity of both field and armature, means simultaneously, then the direction will not change. Okay, the direction will remain constant. So this is the basic fundamental concept of change in direction, and by keeping that concept in mind, I have designed this circuitry, this setup, or rather this module, direction change module, or a drive, you can say anything. Okay, so it can be used in industrial sector, this technique. Okay, this is very much advanced technique. Okay, you can utilize this technique. So basically what is happening, basically this relay is basically responsible for change in direction. Okay, this relay is basically responsible to change in direction, and in this case I am changing the polarity of field. Okay, not armature. To change the direction of the motor, I am basically changing the polarity of the field with the help of this relay. Okay, and this relay is responsible to turn the motor on and off. Okay, so what is the logic here? What is the logic? The logic is very simple. First, the motor will be turned off. At first the motor will be turned off, then means at first this relay will be activated. Okay, means this relay will be not activated, this relay will be deactivated to turn off the motor. Okay, this relay will be deactivated to turn off the motor, and then this relay will do the necessary action. Means then this relay will come into action. Means this relay will turn off, and if it is turned off, if this relay is turned off, means its contact is in NC condition, then it will rotate in, say, clockwise direction. Okay, and if this relay is turned on, means its contact is now in NO condition. Previously it was NC, now it is NO. Then it will rotate in, say, anti-clockwise direction. Means what is happening here? The contacts, what the contact is doing, means at first it was NO, now it has become NC. This tick tock happens, and that with these contacts I've used here to, and these contacts I've used to connect these field winding to change the polarity. Okay, so when the relay is off, it is rotating, the motor is rotating in, say, clockwise direction. When the relay is on, the motor is rotating in anti-clockwise direction. Simple funda. Okay, so to operate this relay, previously I have to operate this relay to turn the motor off. Otherwise, what will happen? The motor will feel a jerk. Hope you are understanding. The motor will feel a jerk, and that can damage the small parts in the motor, say brushes and all. Okay. So see, the video is becoming very much lengthy. I had this circuit schematic representation for your people, for that will make the matter more clearly. So as this video is becoming very long, so if you all are interested to know the more details about this project, then please comment down below, please. If you all want the more details, okay, then I will make a separate video and I will show this schematic representation. I will give a very brief complete detail about this schematic representation, okay, and this code also I will explain the code, okay. So please comment down below, please. So that's it. I hope you all like this video. Then don't forget to like, share and subscribe. Stay tuned with me. Thank you. Have a nice day. Take care. Bye.